Okay, so we're going to graph y equals cosine of 2x. So the first thing you want to do is write down the period, right? So the period, we call it p is equal to 2 pi k. And k is this number right here. This is k. So if I substitute k equals 2, I will have 2 pi over 2, which is equal to pi. That means this function or this equation will complete one cycle from 0 to pi. So here's how you're going to graph it. So the normal cosine looks like this. So I'm just going to draw one period of cosine. It starts up here at 1, and the load's going to go as -1. So it starts up here, goes to 0, and then at -1, 0, back to 1. So
Wait,
that's
wait.
how the usual cosine looks like.
Hold up. So it's
Mhm.
1 and -1 because our amplitude is 1, right?
Right, this is 1.
Okay, and why is the dots over here, like the second one at the X, and then the bottom, and then the up?
So this point right here, this is 2 pi. And this is right here is pi. This is pi over 2. This is
How would
3
I
pi
know
over 2.
that?
So we got that from the unit circle. We derived it in class.
Yeah, really.
Okay. Now we're not graphing this one because this is for cosine of x. We're graphing cosine of 2x. So the graph is shrinked. So you're going to complete the same cycle right here at pi. So it's going to look something like this. We split up the interval into 4 subinterval. So this is pi over 4, pi over 2, then 3 pi over 4, and pi. So you make the same shape. So start right here, go to 0, -1, 0, and then hit 1 at pi. That's the one you're looking at.
Confused. Really confused though.
So if you look about our notes from last time, you'll see how we got the general graph for cosine. And then all you're doing either stretching it or shrinking the graph. Here,
Yeah.
you're shrinking the graph horizontally. So this right here, that's the one for cosine 2x.
But how would I know what points to put down exactly?
Well, so your interval is from 0 to pi, right? You split this up into 4 subinterval like this. So you take the length, which is pi divided by 4, which means this point is pi over 4, and then add another pi over 4, that's 2 pi over 4, add another pi over 4, that's 3 pi
3
over
pi
4.
over 4, and then, okay.
Yeah.
Okay.
That's how you find these numbers right here.
So then if I were to do that, so then, okay, I see how it is with the points. There we go. So
You see
basically,
it?
you just add numbers like then 4 pi, then like the 1 pi, 2 pi over 4, and then you get pi, and then you would add, then I guess you would add like pi over 2, right?
So you're finding the length, right? Length of each
Yeah.
subinterval.
So then after pi, like after like 1 pi, you like put over 2, right?
I don't understand.
Like right over here where it's pi and then 3 pi over 2.
All right. Well, so the ones that are in white, these are on the basic graph of cosine.
Okay, they're basic. Okay.
Those are the basic points. Now, if you have a k value right here, if that changes, then your basic points are going to change depending on the period. So for this question, your period is pi, right? So that's why we take the interval from 0 to pi and split it up into 4 subintervals. And that's how you got this guy right here.
Yeah. So
And
then, okay, so since my k is 2, do I have to like, I don't know, shrink it or stretch it by 2?
well, this one shrinks. So if you look at the white, that's the original, and the blue is the final sketch. So it's shrinked.
Hold up, sorry. Okay, can you repeat that? I'm sorry.
So the white graph is the original, that's cosine.
Yeah.
You're graphing cosine 2x, and you see the graph is shrinked. So it's more shrinked along the x-axis. So if you have a k value that's greater than 1, then it's a horizontal shrink.
And then what happens if, is it possible to have less than 1?
Yeah, you can have a fraction
If
and
it's
there'll be a
less than one,
stretch.
would it like enlarge?
Right, so it's gonna stretch along the
All right,
x-axis.
greater than one strings.
Mm-hmm. All right, any other questions?
And then less than one enlarges.
Kimberly, you said you had a question.
Oh yeah, can you please explain the this is from exam 2, number 4, like the actual test.
Mhm.
It's it's if 1,000 milligrams of a radioactive element decays to 800 milligrams in 1 hour, find the half-life.
800 in 1 hour.
Yeah,
Okay, and we're looking for half-life.
yeah.
Okay, so the first thing you want to do is figure out the model, right? Based on this given info. So the model you're going to use is P of t is equal to P initial times e to the power of RT, right? So this information right here, that means when t is 1, your amount at that time is 800. And this right here, this is your initial amount because that's how much you're starting with. So if I plug these in to my model, I will have 800 is equal to 1,000 times e to the power of r times t, that's 1. So that's the setup for the first statement. And this will allow you to solve for r.
So why wouldn't you subtract like 1,800 and do 200 equals 1,000?
So the reason you wouldn't subtract because it wouldn't make sense because you're starting with this much. After a certain time, it reduces to 800. So that's the setup we come up with. So to solve for r, you're actually going to divide by 1,000, not subtract, because they're multiplying. You see that it's multiplying here, so you'll have to divide to isolate r. Mm-hmm.
Okay.
So you want me to continue solving for r?
Yeah.
Okay. So I will go ahead and divide, right, by the initial amount. So that gives me 8 over 10 is equal to e to the power of r, because r times 1, that's just r. Now, you remember how to solve for r here?
You would multiply both sides by ln.
Right, so we'll take ln on both sides. Good. So this will give us ln of, now you can reduce 8 over 10. That's going to give us 4 over 5, right? Is equal to ln of e to the r. Now, on the right-hand side, ln of e, well, that's just 1. So you can just write this as r. So ln of 1, ln of e will disappear.
Yeah, okay.
So our r is ln of 4 over 5. That's the r. And now let's figure out the model. So the model is P of t is equal to the initial amount, which is 1,000 times e to the power of ln of 4 over 5, that's our r, times t. Now here you should simplify it. Every time you have e and ln like that next to each other, you can cancel them. So your simplified model would be 1,000 times. So when you cancel e and ln, only the input 4 over 5 drops down, and you still have t as an exponent. So that's the model.
Okay.
Okay.
So, oh yeah, so anytime you have the e and the ln next to each other as an exponent, they cancel?
Right. So this
Okay.
is using the property from logarithms. If you have e to the power ln of x, that's just x.
Right, okay.
Mm-hmm. So now we can find the half-life, right?
Mm-hmm.
So half-life means what is the time when the amount P of t is half of the original. That's what you're going to solve for. So I'm going to set this equal to this guy right here and solve for t. Let me know if that makes sense.
Okay. So you take the initial, which is 1,000, and now you divide it by 2?
Mm-hmm.
Okay.
So we take 1,000 divided by 2 is equal to whatever is on the right-hand side. So just rewrite that. And you're solving for t.
Okay.
Good so far?
Yeah.
Okay, now we divide both sides by 1,000 like before. So when you do that, 1,000 cancels. You have 1/2 is equal to 4/5 to the power t. And now you take natural log on both sides. So you'll have ln of 1/2 is equal to ln of 4/5 to the power t. Now again, using the laws of logarithms, you can bring down this power t in front of ln. So this would be t times ln of 4/5 equals to ln of 1/2. Now this, you should also know what it is. Do you remember what ln of 1/2 is?
ln of 1/2. It's like at the tip of my tongue.
So you can use the quotient rule for ln. This is ln of 1 minus ln of 2, right?
Okay.
And then ln of 1 is 0, so this will go away. So it's just negative ln of 2.
Right, okay. That makes sense.
So that's what I'm going to replace on the left-hand side. This is negative ln of 2 equals to t ln of 4/5. And then finally, we just divide by ln of 4/5. So your time is negative ln of 2 over ln of 4/5. So that's the time when the amount reduces to half of the original.
Okay, so if, like, let's say I didn't remember that ln of 1/2 is negative ln of 2, would I still get the correct answer if I just...
Yeah, that's fine.
Okay.
It's just,
That's
if it's
just
a
like...
multiple choice question, you might not see that as an answer.
Oh, right, okay.
Yeah.
So I'll make sure I remember that then.
Yeah. Even in the future, you were expected to know what ln of 1/2 is. Like,
Okay.
I mean, it's something very common and useful to know.
Okay. Thank you.
Sure. Okay, any other questions?
Yeah, I still kind of don't understand how you you said, of course, like shrinking, yeah, of course, but I don't know like what points you have to put down, like pi over 4, that type of stuff. Like how do I determine that it's like pi over 4 I have to put down?
Are you still talking about the same question?
Yeah, it's just confusing me, and so it's just like I really need to like know.
So take a look at this one. What about if I give you a cosine of 1/2 x? How do you
That would
graph
be-
that?
that would enlarge it. That's what you call it. That would enlarge it.
What?
That would enlarge the graph.
All right, but you have to know what points are, right?
Yeah.
Just knowing that is not good enough. So first thing you want to do is find the period, right?
Yep.
So the period is p equals 2 pi over k. Now for this problem, k is 1/2, that's k.
Yep.
So you'll get 2 pi over 1/2, which is 4 pi. Okay?
Okay.
And now for one period, it's going to be from 0 to 4 pi. Now you split this up into 4 sub-interval like this.
0 to 4 pi. So
So you have
Okay.
to find what are these points right here. So the way you're going to do that, you're going to take your length of the interval, that's 0 to 4 pi, and you divide that by 4. That tells you how far you're traveling for one interval to the next interval. So this will just be pi.
yep.
So this is your length of each sub-interval.
Length of each something.
So that means the first point is 0, and then you add pi. So that will be pi. And then the next point you add another pi. So pi plus pi, that's 2 pi. And then again, add another pi, that will be 3 pi. another pi gets you to your period.
So it's kind of like 3 pi plus 4 pi equals 7 pi over 4 or something like that, right?
Yeah, if it happens to be that. Now, all you have to do is come up with a graph. So
Yeah,
this is on the real line. Now put it in the XY plane. So here's our XY plane. What's the amplitude for this one?
what's the answer?
Amplitude,
Oh, amplitude, it's 1.
right? So we're gonna go high 1 and low -1. So cosine, you know how cosine behaves, right? It stops up there, hits 0.
It
and then-
goes down and then it goes up.
Yeah, so those points are right here. We have them, right? These are the points we're gonna place in the x-axis.
It's kind of like a parabola, like the graph of the cosine, kind of.
I wouldn't call it a parabola, but if it helps you.
It's close enough. It's close. Like if you look at like the first part, it kind of looks like it, but then it just goes down again.
Oh, right. So it's like a wave. It's keep going.
It's like a loop, yeah, and that
Yeah,
loop,
yeah,
and that loop looks
exactly.
like a parabola.
So let's finish this up. So this is pi, 2 pi, 3 pi, 4 pi. So I'm gonna start right here and
Yeah,
then go here, right?
I see that's how you do it. Okay.
You see it?
So basically you add up. So basically, how can I explain this? You add it up. So kind of like with 2 pi plus 4 pi equals 6 pi over 4, right? And then you add it up all the way to 4. So like 4 pi plus 4 pi is 8 pi over 4, which then you simplify it to 4 pi pretty much in some way. Like you keep on adding it until you simplify to 4 pi, right?
You're adding this length right here
Yeah.
to get to the next interval.
Yeah. Okay. So you put in the 0 and then that's it, right?
And then you start adding until you get to your period, which is 4 pi. So this is the next point, this is the next point, that's the next one, that's the next one.
So why is it okay? So basically with the oh, okay, yeah, that's I guess.
Right. That's one period. We can continue, but we just need one period. So this is
Yeah.
the-
So the reason why it's 0 plus 4 pi over 4. So the denominator, what is it meant to represent in the denominator?
So this represents the number of subinterval you have. You have one interval here, one
Number
here,
of
one here, one
subintervals.
here. So 4 subinterval.
And then the reason, and basically the reason why it's 4 is because our answer is 4 pi, right?
That's not why it's 4. The reason is 4 because it's 4 subinterval. That's what we divided by 4.
Oh,
trying
so
to
that's
figure
always,
out-
so that's always the case, right?
That's always the case, right? Because those are the
Okay,
4
okay, okay,
intervals we
yeah.
always want to write down.
So it's
Mhm.
always 4. You always divide it by 4.
Exactly.
Okay, yeah. And then
Okay.
I guess from there you do 0 plus whatever you have, like for example, 0 plus 2 pi over 4.
Yeah. Yeah. Whatever the
Okay.
length is, you keep adding until you get to the last point on the
All
interval.
right, I'm starting to understand it a little bit. Can we go over sine now? Like sine?
It's the same thing, sine and cosine, just different graph.
Oh, just different graphs. You just
Mhm.
kind of like, oh,
Yeah.
they're the same thing. No, because I know it's like a different trend that they have.
Well, for sine, if it was still the same period, right? It will start here and then you just make that curve.
Yeah, no, I
something
was
like that,
thinking,
right?
yeah, okay. I need to
That
kind of
open.
like remember that trend as well.
Yeah, so you just follow the same pattern.
And then if it's so kind of like, can I share my screen real quick?
Sure.
All right, yeah.
So for period, we use the formula P is equal to 2 pi K. So you want to remember that, okay? And K is this number right here. That's your K. So it's the number right in front of X. So for this equation, period would be what? 2 pi over 4, right? Which is pi over 2. So that's the period for this function. Let me know if that makes sense.
So you just take the like the 4x, you put in the bottom, and then you put always is 2 pi.
It's always 2 pi over K. K is the number right in front of X. This is your K. So
Okay.
I just replace it where K is.
And how would you graph that?
So for graph, you have to find the 5 points, right? So for the interval of one period, it's 0 to pi over 2. That's where you're going to complete one cycle. That's what this number means. So what you do, you subdivide the interval into 4 sub-intervals, and you have to find what these points are. And the way you're going to do that, you're going to take your period, which is pi over 2, and divide that by 4, because you're looking for 4 sub-intervals. And that would give you pi over 8. Let me know if that makes sense. So then the first point here, it's going to be pi over 8. The second point, it's going to be pi over 8 plus pi over 8. So that will be 2 pi over 8. And then the next point is up plus another pi over 8. That's 3 pi over 8. And then 4 pi over 8 gives you pi over 2. You see that?
Yeah.
Let me know if you have questions.
Can you go up real quick? Sorry.
What's that?
Can you go up real quick? I just kind of want.
Uh-huh.
Oh, okay. Yeah. Okay. I see why it's 5 over 2. Okay.
So now we put this on the XY plane and
And then
come up
it's
with the
that
sketch.
pi over 2 over 4 is like the 0 plus pi over 2, right?
Right, because
Okay,
0 plus
Okay.
infinity.
Okay. Gotcha.
Yeah.
Gotcha.
Mm-hmm. So what's the amplitude here? That's 1, right? Amplitude is 1. Which
I
means
have
the
a
graph.
question.
Mm-hmm.
If you have negative cosine, that means amplitude is -1.
No, the amplitude is still 1. It's the absolute value of this number right here.
Oh, okay.
Negative just indicates it's a reflection over the x-axis.
Okay.
Mm-hmm. Okay, so now you want to see the sketch? So here's 1, here's -1. So remember how cosine behaves, right? It starts at the maximum and then it just loops around. And these points right here, we're going to put them right on the x-axis. So this is pi over 2. This is pi over 8. This is, so 2 pi over 8, you can simplify that to pi over 4. And then 3 pi over 8 right here. So cosine will start at its maximum and then goes down to 0. Then at -1, 0, and at 1. And you just make the curve. Something like that. And of course, it continues on. Let me know if this makes sense.
Yeah, it does make sense.
Kimberly, did you have any question?
Yes, I have one from the second exam as well. It's to graph a function. It's j of x equals x squared parentheses x minus 7 cubed.
Okay. So this is related to section 3.2, where you have higher order, right? Higher degrees. The first thing you want to do is find the zeros. So do you know how to find the zeros?
Yes, you're gonna you set y equals to 0.
Mm-hmm. So we're going to set j of x equals to 0 because that's our y. So you'll get 0 equals x squared times x minus 7 cubed, which means x is equal to 0 and 7. These are the two zeros. Now zeros are also x-intercepts. Okay? And now we're going to see where this graph is positive or negative. Now let's take a look at the degree first. What's the degree of this polynomial?
The 2.
Well, this one and this one, right? You have to add them up.
5.
5. So it's an odd power, right? And the leading coefficient is also positive. So that means it's going to behave like the usual x cubed, like that. That's the end
Mhm.
behavior. So now that we know the end behavior, we can put it together with our zeros. So here is 0, here is 7. Now the two ends, this end and this end, it's going to be our end behaviors. So you can say that this end it's going to be negative, this end it's going to be positive because of that. So that saves you some time by not doing the test values. But if you want to do the test values, you'll get the same sign. Now, what about here? What's the sign between 0 and 7? How do we determine that?
Hmm. Wouldn't you have to replace x with 0?
Not 0, anything in between 0 and 7.
Oh, anything in okay, so like
Yeah.
just a random number, like
Mhm.
5 or something.
Yeah, let's go
Or
with
1.
1. Yeah,
Okay.
1. 1 is easy, right? So if you plug that back into the original, do you get a positive value or negative value? So you'll do 1 squared, right? 1 minus 7 cubed. So that would be a negative number.
Yeah.
Okay, so this is negative. So now we can come up with a graph. So here's our XY plane. Plot the zeros first. So I have a 0, 0, and then 7, 0. So negative means you're below the x-axis. Positive means you're above the x-axis. So you make a smooth curve like this. Negative, negative, positive. Something like that. Roughly sketched, right?
Yeah. Okay, I see where I went wrong now on the exam.
Okay.
Yeah.
Okay. Does it make sense now, though?
Yeah, it does. Thank you.
Sure. All right. Any other questions, guys?
Yes, I have a question from the first practice exam.
Mm-hmm.
It's like a graph, and you have to find the y-intercept, the x-intercept.
Mm-hmm.
I don't know how to like.
Well, if you're given the graph, then you just look for where it crosses the x-axis and the y-axis, right? Are you given graph or equation?
Equation and a graph.
So give me the equation.
Y equals 5x minus x squared.
Okay, so let's graph it. Now, do you know how the graph, what this equation look like?
Probably like the u, but it's down.
Mm-hmm. Good, because of this, right?
Yeah, because of the negative.
So let's find the x-intercepts. So first we'll find the x-intercept. So we'll set y equal to 0. You'll have 0 equals 5x minus x squared. Factor the right-hand side. So I'll plot an x. That'll give me 5 minus x. So the x-intercepts are 0 and 5, right? So if you graph it, it will look something like this. So we'll go through 0, 0. That's one of the intercept. And it will also go through 5. And you just create a parabola, right? So there is a vertex somewhere right here. So I'm going to do my best to draw this. All right, that's weird. Let me redraw it. Okay. Sorry, guys, I can't draw parabolas anymore. Looks like I forgot how to draw them. All right, what the heck? Sorry, it doesn't draw. Okay, is this better? Can you guys believe this is a parabola?
Yes.
It's weird, right? Okay, so can you tell me what are the x-intercepts and y-intercepts? So this is one of the x-intercept. In fact, we actually computed that, right? right here.
So the x-intercept will be like 0, 5.
Well, it's 0, 0. That's the first one I boxed, right?
Yeah, and 0, 5.
No, 5, 0. X-intercept, y is 0. X coordinate is 5, y coordinate is 0. So that's this point. Do you see it? So it's not 5, 0, 5, it's 5, 0.
Okay.
Because your x coordinate is 5 and the y coordinate is 0. That's how you solve for it, right?
Yes.
And then what about the y-intercept?
Is the highest point.
No, that's the vertex. This right here, that's the vertex. Y-intercept is again this one, because that's when the graph crosses the y-axis. Right? So the y-intercept will be again 0, 0. So that same point, the origin, happens to be both x and the y-intercepts. Let me know if that makes sense.
Yeah, is it always the case? Like,
Not always. I could shift the graph, right? And then the
yeah,
intercepts are going to change. So for example, if I give you, let's say, this graph. So say I give you this one. Something like that, right?
Mhm.
Now, here's an intercept, here's an intercept, here's an intercept. So let's label them. So let's say this is -3, this is 1, this is 2. So by looking at this graph, can you tell me the x-intercepts and the y-intercepts? Well, how many x-intercepts do we have?
the x-intercept is like the -3 and the 1.
Right, so write them as a coordinate.
So that's 0, 1.
No. Remember, for x-intercept, y is 0, always. So this one right here, you're gonna say that's 1, 0, y is 0. And then this one right here, that would be -3, 0. Let me know if that makes sense.
Yeah.
Okay, so for x-intercept, y is always 0. For the y-intercept, x is always 0. So when you write the coordinate, you start with x equals 0. And now you read off, okay, where does it touch the y-axis? It touches the
2.
y-axis at 2, exactly. So it'll be 0, 2. Those are the intercepts. Let me know if you follow.
Yeah, I understand it.
Okay. So always remember, for x-intercept, y is 0. For y-intercept, x is 0. Magda, any other questions?
Yeah, I have a question on 49. Like,
Tell me the question.
okay. F of x equals to x to the 4th power divided by no, never mind.
Okay,
I got it.
you got it. Okay.
Oh, I have a question from
Uh-huh.
exam 1. So it's to find the domain of the function f of x equals x plus 1 over square root of x. And then it says to do it using interval notation. And then the next part of it is to let f of x equal 2 over x plus 4. And then determine the net change and the average rate of change between x equals 1 to x equals 2.
So there are two separate questions.
Oh, they are?
Yeah, so
Okay.
the second one is not related to the first one.
Oh, can you do
Okay.
both of them anyway?
Okay,
that's okay.
so let me do this one and then I'll take the next one from you.
Okay.
So for domain, right, we have to make sure that the denominator is never 0. Now, for this one, because we have a square root in the denominator, we have to make sure it's not 0 and also it's positive. So you want to make sure the quantity that's inside the radical is always greater than 0. And that's pretty much it. That's the domain. So in interval notation, you can say the domain of f is starting from 0 all the way to infinity. That will be it. And we don't have to consider the numerator because it's just a polynomial. So you can plug in anything you want, but the denominator is the trouble. So you want to make sure this makes sense. And it makes sense only when x is greater than 0. Let me know if you understand this.
Yes, I understand that part. Oh, and actually, now that I'm looking at it, I got the second part right.
Mm-hmm.
So I'm good with that next question. But I do have a question about finding like the center and radius of a circle.
Okay.
So this one is x squared plus y squared plus 4x minus 14 equals 0.
And we're looking for the center and radius. All right, so for this, you have to complete the square. So we're going to rearrange the terms. So I have x squared plus 4x, leave a space. Then you have y squared, and there's no linear factor for the y term, so no need to complete the square for y. And negative 14, move it to the other side, so it's just 14. Now, do you guys remember how to do completing square? Anyone remembers how to do that? So for completing the square, you're going to take half of this term right here and you square it. Okay, so I'm going to take half of 4 and then I square it. I get a number that will be 2 squared. That's 4. That's why you replace here. Now to keep things balanced, you also add 4 to the other side. That's the rule for completing the square. Now, the x variable will factor into x plus 2 all squared. The y, leave it alone, equals to 14 plus 4, that's 18. So that's the standard form of a circle. Let me know if this makes sense.
Yeah, it does.
Okay, now, can you identify what the center is?
Would it be 2, 18?
Well, not exactly. So this looks like x minus h squared plus y minus k squared is equal to some r squared, right? That's the standard form of a circle where the center is h comma k. So these are the coordinates for your center. And this number right here, that's your radius. So if you look at the one we have, this will be the coordinate, x coordinate for our center, opposite of that. And for the y variable, there is nothing really next to it, right? So you can write it like this, y minus 0 squared, if that feels good. So this would be negative 2 comma 0. That 18 will be the r square value. So the radius is a square root of 18. Now you can leave it this way, or you can simplify this because 18 is 9 times 2. So if you take square root of 9, you'll get 3 square root of 2. That will be r. Any of these are acceptable.
So in that equation, the x minus h one, to find the center, you basically just take the opposite.
Mm-hmm.
Okay.
Yeah.
That's clear now. Okay,
So,
thank you.
So for example, let me just add on to this. If I give you, let's say, x plus 2 squared plus y minus 7 squared is equal to 10. What would you tell me about the center and the radius?
The center would be -2, comma 7.
Mm-hmm.
And then the radius is the square root of 10.
Exactly. There you go. So once you
And
have
like-
it in standard form, it's easy to identify. Go ahead.
Okay. Oh, sorry.
Mhm.
So if it does, so how do you know whether to square root it or to square, if that makes sense?
So when you have it in the standard form, like this, then this number, the right-hand side, 10, this is already r square. This is
Oh, okay.
equivalent to r square, right?
You
Because
go
that's
up
what
real
we
quick,
have in the
so you
equation.
go up.
Uh-huh. So that's why
Oh,
you know
okay.
you have to
Oh,
take
okay.
the square root.
Oh, okay, to get the center, it's kind of like, how would I explain it? Oh, okay, you just divide it by 2 or whatever. In some way, I think, right?
When
Like the
I'm not
center, like,
sure.
like the center is like 4, but like 4x, but then like it's a 2.
It's not 4x. We had to complete the square to get to the standard form. And then you look at the equation in standard form to identify the center. Okay, Kimberly, does that make sense?
Yes, it does. Thank you.
Okay, sure.
All right, I don't think I have any other questions. So,
Okay,
thank you.
yeah, no problem. All right, so Magda has a question. So let's go ahead and find the domain of this function. So f of t is equal to the square root of t plus 8. So what is the domain of f? Now for this one, there's no denominator, right? You can think of denominator as 1. So the only thing we have to worry about is making this quantity positive, always. So I want t plus 8 to be greater or equal to 0. Now here being equal to 0 is fine because it's in the numerator, not in the denominator. So to solve for t, we subtract 8. So t has to be greater or equal to -8. So that's the domain. But of course, you want to write it in interval notation. So the domain of f would be starting from -8 to infinity. That would be the domain.
Isn't it like union to a to infinity? Or we don't have to include that?
8 to infinity?
I mean, see right here, I thought like it was going to be -8 to infinity union.
Well, not negative infinity because this is greater than 0, right?
Yeah.
So the negative piece doesn't come into the picture. If you draw this on the real line, here's -8, and we're looking at from -8 to infinity right here. So there's no union, like there's no two pieces to connect. It's only one piece. So you could just write it like that. So do you want something that contains more than one piece?
Yeah, I want to say like the difference between them, yeah.
So let me give you so I'm going to modify this question a little bit. So take the same function and do this. A square root of t plus 8 divided by t. What will be the domain of f? So again, you do the same thing, right? You want to make sure the numerator is satisfied and the denominator is also not 0. So for the top, we already know we have to look at everything from -8 to infinity, right? Because we already did that previously right here. Now the denominator, when will the denominator be 0?
It would be 0 when t is equal to 0.
Yeah, so we have to remove 0 from that interval. So now putting both of these together, you might want to draw a picture before coming up with the interval notation. So -8 right here, 0 right here. So we want everything from -8 to infinity. But as we get closer to 0, well, 0 cannot be in it, or else it makes it undefined, right? And then 0 to infinity is good. So this is what you're going to write in using two different pieces. So the first piece will be -8 to 0, open at 0, union, again, from 0 to infinity. So that will be the domain of this function. So do you see how the union is being used for something like this?
Yeah.
Let me know if you have any questions. All right, any other question?
I have a question for the third exam. When is like how to solve for sine, cosine, and tangent.
Mm-hmm.
Like if I have sine 11 pi over 6.
Mm-hmm. Oh, how to find the exact value?
Yeah, and how to find the terminal point.
Okay, so let's do did you say 11 pi over 6?
Yeah, sine 11 pi over 6. Yeah.
Okay, so let's find the exact value of sine of 11 pi over 6. Now, since this angle is bigger than 90, you have to find the reference angle. And you also have to remember 30, 45, 16. They're exact values. Now, how large is 11 pi over 6? How do we know that? So one way you can convert, right, to degrees, or you can just rewrite.
I thought like you do 180 over pi.
So you can do that. So 11 pi over 6 times 180 over pi to convert, right? So then if you do this, what do you get? So if you have a calculator, help me out. What's 11 times 180 divided by 6?
$330.
Okay, thanks. So this is 330 degree. So now you can just rewrite 11 pi over 6 as sine of 330 degree. Now that's easy to work with, right? Let's draw the angle so we can find the reference angle. So 330 degrees in which quadrant? So you start from standard position, right? Which is positive x-axis, and go around, and somewhere right here will be 330. Let's say this is 330 degrees. The reference angle is this angle right here. That's your reference angle. So what is the reference angle? So it'll be just a little bit more that get to 360, right? So 360 minus 330. So the reference angle in the fourth quadrant is 360 minus 330. And that would give you 30 degrees. So now I can replace this angle with the reference angle, but I also have to make sure I have the correct sign. So we use this acronym, right? ASTC. C means only cosine is positive on the fourth quadrant, so sine will get a negative sign. This is a negative sine of 30 degree. And now from memory, do you remember what sine of 30 is?
It's 1/2.
You got it. This is
Negative. Yeah.
There you go. That's how you find the exact value. Now, when we ask for terminal point, then we actually ask for both sine and cosine. So I'm going to take the same question and just change the instruction to, instead of exact value, I'm going to ask you find the terminal point. So check this out. So what if we're looking for the terminal point of theta equals 11 pi over 6, which you know already, that's 330 degrees, right? So for terminal point, we want the x coordinate and the y coordinate. And x is represented by cosine. So looking for cosine of 11 pi over 6 and sine of 11 pi over 6. And we already know sine of 11 pi over 6, right? But cosine, we have to figure it out. But we know 11 pi over 6 is a 30-degree reference angle. So this would be equal to cosine of 30 degrees, comma, negative sine of 30 degrees. And now from memory, do you know what cosine of 30 degree is?
2 over.
What is it?
Oh, I said 2 over 2.
Not 2 over 2.
I mean,
2 is
square
fine.
root 2 over 2.
That will still be incorrect.
That's 1/2.
No, not 1/2. Sine of 30 is 1/2.
Oh, wait, no, I know. Square root of 3 over 2. Yeah.
So this is square root of 3 over 2, and the sine of 30, we already did that previously, so that will be the terminal point. So that's how the two questions can vary. Let me know if this makes sense.
Yeah, makes sense.
Okay. All right, so I'm gonna stop here. Are you guys okay with doing the rest on your own? I don't
One
have
last
any
question. I
last-minute
have a last
question.
okay. About the half-life. I have a question about it. So let me copy and paste it here in the chat.
Okay. Okay. So after 3 days, a sample of radon-22 has decayed to 58% of its original. So when T is 3, the amount is reduced to 58%, which is 0.58 of the original. What is the half-life? Okay, so this right here will help you to find the rate, R, okay? So we know that, so we're using this model, P of T is equal to P naught e to the RT. So we don't know the initial, and it doesn't matter really. So use P naught for initial. So we have 58% of the original is equal to the original times e to the power of R times 3. So that's the setup for this first statement. Now this will allow you to solve for R. Divide both sides by the initial amount. So you will have 0.58 is equal to e to the 3R. And now we take natural log on both sides. So we have ln of 0.58 is equal to 3R, because e and ln, that's just 1. And then you divide by 3, so you have 1/3 ln of 0.58 is equal to R. So that's the rate at how this is decaying. Now, once you have your rate, write out the model. So the model for this particular scenario would be P of T is equal to P naught times e to the power of R. That's 1/3 ln of 0.58 times T. Now, I was telling this to Kimberly earlier, that if you have E and ln next to each other, you want to cancel them. Now, in this case, we can't really cancel them because of the 1/3 in front of ln. So first, what you want to do is make 1/3 as an exponent and then you can cancel. So I'm going to rewrite a little bit. This is P naught times e to the power of ln of 0.58 to the power 1/3 times t. And now you can cancel this. You remember that, Kimberly?
Yeah. I
We
remember
did that, right?
Mhm.
So now I can cancel them. So I have some P naught times 0.58 to the power t/3, because 1/3 times t will be t/3. So that's your model. Now using this model, we can answer the question. We're looking for half-life. Well, half-life just means what is the time when the amount at that time is half of the original. So I'm going to replace P of t with this so I can solve for t. Here's how it's going to look like. You'll have the initial over 2 is equal to the initial times 0.58 to the power t/3. You're solving for t. Magda, let me know if we're okay so far.
Yeah, we're dividing by 2 because of the half-life, right?
Half-life, right? Half means half of the original. What is the time? Now divide both sides by P initial. So you have 1/2 on the left is equal to 0.58 to the power t/3. And now we can take natural log again to solve for t. So this is ln of 1/2 is equal to ln of 0.58 to the power t/3. Now here again, you're going to use the laws of logarithms to bring this forward. So you'll have ln of 1/2 is equal to t/3 times ln of 0.58. Now you should also remember what this is. Magda, do you know what ln of 1/2 is?
Like you have to take the ln in both sides. No.
Well, you separate it by using the laws, right? So ln of 1 over
Yeah, you bring the 1/2 to the like 1/2 ln. You move it, right?
well, you don't move it, you write it like this. This is ln of 1 minus ln of 2, the quotient rule,
Yeah.
right? And then ln of 1 is 0, so you just have negative ln of 2. So ln of 1/2 can be written as ln of 2. Negative ln of 2, sorry, negative ln of 2. And this is equal to t/3 ln of 0.58. Let me know if you follow.
Yeah.
Okay, and now how do we solve for t? Well, we multiply and divide, right? Multiply by 3, so you have negative 3 ln of 2 is equal to t times ln of 0.58, and then divide by ln of 0.58. So t is going to be negative 3 ln of 2 over ln of 0.58. So that's the time for the amount to reduce half of the original, or that's your half-life. This is the half-life. Any questions?
The second part B is like, how long will it take the sample to decay 50% of the original amount?
So now you go back to the model, right? And then instead of setting it to half of the original, you set it to 15% of the original. So you will set it to 0.15 of the original, and then do the same thing we did. So for t.
Okay.
Okay. All right, so I'm gonna stop here, okay?
Okay.
All right.